So once again, I'm back with the object-oriented programming. So today's class we'll discuss about many topics. Like first of all, we understand the definitions of some important concepts, and then we'll discuss much more about concepts, about some examples of programming with C++. So today's class we'll discuss about object and classes. First of all, we'll discuss about some definitions, some important definitions about encapsulation, abstraction, polymorphism, classes, messages association, and interfaces. So I think most of the topics were already discussed in the previous classes, but still we will brush them once again. Okay, so that it's very much useful for us. And then we discuss about the implementation of class, a general class in C++, and how we consider C++ objects as physical objects and C++ objects as data type constructors, how we treat as object as a function arguments, about the default copy constructor in C++, how you return object from function, and about the various structures and classes. And we discussed about the class objects and memory static class data, and then we discussed about the const as well as classes. Okay, so this is especially for you, my dear students and young researchers, and this is Professor Dr. Christo Ananth for you. You can reach me at dr.christoananth@gmail.com. So before beginning the session, let me once again thank you God for giving me this golden opportunity to deliver this useful session, to share my knowledge among my fellow national, international participants, students and young researchers. So today's class, as I told you, we'll discuss about the definition of encapsulation, abstraction, polymorphism, classes, messages association, and various interfaces. So these are the basic concepts, and then the basic definitions, and then we'll discuss about some concepts like implementation of a class in C++, C++ objects as a physical object, C++ objects as data types, about the constructors in C++, how you treat objects as function arguments, about the default copy constructor, how you return object from function, about the various structures and classes, and how you define classes, objects, and memory static class data, and finally we end up with the const as well as classes. Of course, at regular intervals I'll be giving you some short videos to explain the knowledge in our topics, and I've already posted the independent work, the last independent work of object-oriented programming in the Google Classroom. Please go through them, and after this I'll be posting an open-ended project. So it's pretty much open-ended. So you can choose an application-oriented one, and you can submit them. So accordingly, you will be getting your marks. Right. So first of all, we'll try to define what is encapsulation. I hope you would have gone through the topics. We had already discussed this one in second lecture about encapsulation. So once again, I am telling you that encapsulation, we are wrapping up of data and information under a small unit, under a single unit. In terms of object-oriented programming, you can define encapsulation as binding together data and functions which manipulates them. For example, in the case of encapsulation, maybe in a company, there are different sections, maybe account section, finance section, sales section. Okay. In the case of finance section, you will be handling all the financial transactions, and you keep records of all the data which is related to finance. Okay. Similarly, you take in the case of a sales section, it is going to handle all the sales related activities, and it is going to keep the record of all the sales. Now let us take in the case, some official from the finance section wants to get the data about sales in a particular month, which means that he is not allowed to directly access the data of the sales section. Okay, so you have to request it. Okay, you will have to contact some other officer in the sales section. You have to request him to give the particular data, and that particular data need not be the entire data. Okay, maybe that data which is needed to be known, it can be shown. Okay, so this is what encapsulation is. So the data of the sales section and the employees that can manipulate them are wrapped under a single name called as the sales section. So you can very well conclude that encapsulation also leads to data abstraction or maybe hiding. The case with the access specifiers, definitely with the help of access specifiers, we can easily implement encapsulation in C++, and the way in which you try to implement the encapsulation can be divided into two steps. One is the private access specifier, and the other one is public access specifier. So here the data members are private using the private access specifiers, and in the public access specifier, the member function which manipulates the data members, definitely they will be termed as public. Okay, so this is private access specifier and public access specifier. Then you have abstraction in C++. So definitely it is considered to be the most important, most vital part of object-oriented programming in C++. So in abstraction, you are displaying only the necessary information and you are going to hide the details. So only the essential information about the data is shown to the outside world, whereas the background details or maybe implementation part, you are going to hide it. It need not be known to the public. Let us take in the case we already discussed this one. A man driving a car. A man only knows that pressing the accelerator can increase the speed of the car, or maybe if you try to apply the brakes, it will stop the car, but he does not know about how the process takes place. Maybe after pressing the accelerator, how that speed is actually increasing, or maybe pressing the brake, how the speed is being controlled. He doesn't know. Okay, so this is abstraction, and the similar case it extends in C++ also. So you can implement abstraction using classes, and you can implement this abstraction in header files too. In the case of classes, definitely class helps us to group data members and member functions using available access specifiers, and a class can decide which data member will be visible to the outside world and which data member is not visible to the outside world. Similarly, in the case of the header files, okay, you can consider a power method to be present in the math.h header file. So whenever we need to calculate the power of a number, we simply call the function pow, P-O-W, which is present in the math.h header file, and you pass the numbers as arguments without the the underlying algorithm according to which the function is actually calculating the power of numbers. So this is how you present, you call the function, okay, a power function, and you pass the numbers as arguments. So access specifiers definitely are considered to be the main pillars of implementing abstraction in C++, and you can use the access specifiers to enforce the restrictions on class members. So definitely the members which are termed as public can be accessed from anywhere in the program. For example, if we are setting the members to be private, it can be only accessed from within the class, which means that it cannot be accessed outside of the class or from anywhere in the program. So next we have like polymorphism, which means that we are trying to display them in more than one form. You can take it in several forms, and polymorphism, using polymorphism, we have the ability of a message to be displayed in more than one form. So with the case of polymorphism, a person at the same time can have different characteristics. As I told you, I am a person who is teaching you object-oriented programming. Maybe in my home, I cannot be teaching object-oriented programming all the time. I should be a responsible father to my daughter, and a more caring husband to my wife as well. Okay, and similarly the same thing, like when I'm working in an organization, I shouldn't be the same as I am in home. Okay, so the same person possesses different behavior in different situations. So this you call to be polymorphism, and polymorphism you can extend the same in object-oriented programming. So this polymorphism is considered to be a very important or maybe a very vital part of object-oriented programming. So here we subdivide polymorphism. Here we have compile time and then run time, and then compile time we have function overloading. I think we already discussed about overloading functions in C++, and then operator overloading as well. And in the run time or maybe the execution time, we have virtual functions. So this is the subdivision of classes in the polymorphism. So when you talk about classes, definitely it is considered to be a building block of object-oriented programming. And this class is a user-defined data type, which is going to have all its data members and its functions, which can be accessed and can be used by create a small instance of that class. So maybe a C++ class is considered as a blueprint for an object. Let us take an example. You consider the class of cars. There might be different cars with different names, with different brands, but definitely every car will have its property. Like it will have 4 wheels, it will not have 2 wheels. There is no car which has 2 wheels. Every car has 4 wheels, and every car has a speed limit, the mileage. Okay, how much diesel it consumes. Okay, what is the make? Okay, so these properties remains the same. Okay, so these are the properties like the class. Okay, so you consider the car to be a class, and maybe wheels or maybe speed limits or maybe tire or maybe mileage you consider as the properties, okay, of the classes. Similar thing, you extend this in C++, where you associate, okay, the members of the class. So here an object can be related with another object with the following relationship. For example, the associated object is otherwise unrelated to the object which is class. Okay, so member is different from class. Okay, and an associated object, okay, which is a member, can belong to more than one object or class at a time. And similarly, the associated object, called the member, does not have its existence managed by the object of class, and the associated object of member may or may not know about the existence of the object of class. Okay, so this is how you qualify for a message association between one object to another object in C++. So unlike composition or aggregation, definitely it's considered as a part of the whole object, and in an association, the associated object is otherwise unrelated to the object. So just like aggregation, the associated object can belong to multiple objects simultaneously, and it is not managed by those objects. So however, unlike this aggregation, where the relationship is always unidirectional, definitely in an association, the relationship can be, somebody tries to ask a question, then you try to reply. So it is bidirectional. Also, similarly, just in the case of the teaching, when you are keeping quiet, it is unidirectional. Okay, so this is also association, but in aggregation, the relationship is always unidirectional. So with the case of association, the relationship between the doctors and the patients is association. Okay, the doctor really has a relationship with his patients, like how the patient is taking the medicine, how the patient is recovering, developing. Okay, so this is association, but conceptually it's not a part or maybe whole relationship. Like for example, the doctor prescribes and now the patient gets the ideas, okay, and he or she will try to follow the medicines what the doctor has prescribed. So it is not a complete relationship, but it is it's not a part or maybe a whole relationship. Maybe a doctor can see many patients in a day, and a patient can see many doctors, okay, perhaps if they want a second opinion. But neither of the objects' lifespans are tied to each other. Okay, so it's not limited. So there are several interfaces in C++ as well. So with the case of interface, you are going to describe the behavior, or maybe you are going to describe the ability or capability of a C++ class without committing to a implementation of that class. So in the case of C++ interfaces, you implement using abstract classes, and these abstract classes you shouldn't confuse with the data abstraction. Okay. So in the case of data abstraction, you are going to keep the implementation details separate from that associated data. So you can generally conclude that a class is made abstract by declaring one of its functions as its pure virtual function. Now that we are going to implement the class in C++, this is a very good example of maybe KFC. Like we have created a class called franchise, and then inside that class we have two functions, KFC and Burger King. Both of them, now with the access specifier, you specify it as public. So inside the main function, there is an object fran of class franchise, and then you will call both these functions KFC and Burger King with the help of the object fran using the dot operator. Okay. So by calling both the functions, the message inside that function is being displayed. We'll consider an example. Okay. So hash include iostream using namespace std class franchise. Within the class franchise, you are going to set the term as public void KFC cout we have the best chicken. Okay. And then n1 void Burger King cout we have the best burgers, and then n1. Okay. And then you are going to start with int main franchise fran. Okay. Okay. Fran.kfc and then fran.burger king. Okay. And finally you are going to return 0. Now when you try to run this one, okay, so you will have C users hash desktop. You are going to change the directory to C users work temcode runner file. So we have the message, we have the best chicken, we have the best burgers. Okay, so it's all about the franchise. So next we go to the C++ objects as physical objects. So objects in programs, definitely you will represent C++ objects as a physical object, which means that you can feel it. Okay, it can be seen. And these situations definitely will provide vivid examples of the correspondence between the program and the real world. And similarly, you consider the widget parts as objects, in which you take an example of small object class, and maybe we'll go for creation of a class based on the structure for the widget parts inventory. Okay, so we'll try to analyze something called structures, which are considered as physical objects in C++. Okay, so here you have the object part as C++, widget part as an object. Here you go for hash include iostream using namespace std function. Class part, you define the class, and then here you set it as private. Okay, the model number. Okay, so this you are setting it as private in part number, and then float cost. Okay, and then public you are going to void set part in mn int pn and then float c. So this you are going to set the data. Okay, and then you start the brace model number, it is mn, pn is actually part number. Okay, and then c is cost. Okay, and then you are going to go for void show part. Okay, display data. So here you print the model, which is model number, part which is the part number, and cost which is the cost. Okay, and you are going to end the braces, and then you are going to go with int main part1. Okay, you are going to define the object, and then you are going to call the member function like part1 dot set part 6244, 373 217.55f. Okay, and then you are going to go with the show part, which is the call member function, and finally you are going to return 0. Okay, so this is how you treat the C++ objects as a physical object by calling the member function and displaying the model number, part number, as well as the cost. Okay, so whenever you go with this class, small object class, we will have like model number, part number, and cost. And a single member function, maybe a set part, definitely it will supply value to all the 3 data items at the same time. Similarly, with the case of show part, it is going to display the values stored in all the 3 items. Okay, so only one object of type part is being created, which is part 1, and maybe like 6244 or maybe 373 or maybe 217.55, it is going to display the values. Whenever you have like show part, it is going to display the values. So when you run this, actually this program, okay, so you will have the model number 6244, part number it is 373, and the cost is actually $217.55. So this is how you display with the help of show part. We now move into C++ objects which are considered as data type constructors. So definitely you can term or define constructor to be a very special type of member function of a class which initializes object of a class. So generally in C++, here the constructor is automatically added when the object or maybe a small instance of class created. So it is considered as a special member function of the class because it doesn't have any return type. In the case of constructor, you don't have a return type. So it is definitely different from the normal member function. Like a constructor has the same name as the class itself, and constructor, as I told you earlier, it doesn't have a return type. A constructor is automatically called when an object is being created, and it should be placed in the public section of the class. Okay, so if we are not specifying a constructor, which means that the C++ compiler is going to generate a default constructor for the object, which means that we have like no parameters and it has like an empty body. So definitely it's different from the normal member function. Like it doesn't have a return type. It is having the same name as the class name. Okay, and it is automatically called when the object is being created, and it should be placed in the public section of the class. And if we are not specifying a constructor, which means the C++ compiler is going to generate a default constructor. And we pass these objects of the class as arguments to the member functions. Also, we are passing this objects of the class to the non-member functions as well, either by value or by reference. So when this object is passed by a value, so a copy of the actual object is created inside the function, and this copy is destroyed when the function terminates. So any changes made to the copy of the object inside the function are not reflected in the actual object, and in the case of pass by reference, only that reference to that object is passed to the function, not that entire object. So which means that the changes made to the object within the function are also reflected in the actual object. So when an object of a class is passed to the member function of the same class, its data members can be accessed inside the function using the object name and the dot operator. So the data members of the calling object can be directly accessed inside the function without using the object name and the dot operator. So this we are explaining with the help of a program of how we pass this object as function arguments. Hash include iostring.h class weight. So here you input this kilogram, gram, okay, and then you are going to set it as public. Void get data, void put data, void sum weight, sum underscore weight. Here you go with the parameters weight comma weight, okay, and then you close the brace. And then with the case of void weight, you get the data like C out, you are going to print the kilograms, okay, input, you are going to get the weight in kilogram. Okay, and C out you are going to print as grams. Okay, C in it is gram, and void weight similarly like get data you are going to put data. C out kilogram it is kgs, and gram in gross. Okay, grams. Okay, and similarly finally you are going to go with the addition void weight sum underscore weight. Okay, weight w1 and weight w2. So this weight w1 and weight w2 you are going to add. The gram equal to w1 dot gram and plus w2 dot gram. Okay, and kilogram is equal to gram slash 1000, and gram equal to gram modulus 1000. Okay, so kilogram equal to kilogram plus w1 dot kilogram plus w2 dot kilogram. So this is the total kilogram, and then you go with the main function weight w1, w2, w3. So here you are going to go with C out, enter weight in kilograms and grams, and C out you are going to first of all enter the weight hash 1. Okay, and w1 dot get data you are going to print. Okay, C out enter weight hash 2 you are going to go with the input of w2 dot get data. Similarly w3 dot sum underscore weight w1 and w2. So C out weight hash 1. So w1 dot put data. So you are going to put the sum. Okay, so w1 dot put data, and C out weight hash 2 w2 dot put data, and finally C out total weight equal to. Okay, so it is w3 dot put data. Okay, and then return 0. So whenever we are going to go for the output, okay, enter weight in kilogram and gram. Enter weight hash 1 kilogram 12. Okay, grams 60. Enter weight hash 2 kilograms 24. Okay, so and then you are going to go with grams 850. So it shows like weight hash 1 12 kilogram and then 560 gram. Okay, 24 kilogram and then 850 grams. So it is going to add them. Okay, so grams and the kilograms it is going to add them, and it is going to show 37 kilograms and 410 grams. Okay, so this basically is going to add them, and it is going to print the result. So here in this example, as you have observed, so this sum underscore weight function definitely it is having direct access to the data members of the calling object. So however, the members of the object which is passed as arguments can be accessed within the function using the object name as well as the dot operator. Okay, so you can say that w1 and w2 you are passing it as values, but however they can be repassed by using reference also. Okay, so to pass w1 and w2 by reference to the function sum underscore weight, generally the function should have to be declared, and definitely it should be defined. Okay, like we have an example void sum underscore weight ampersand weight ampersand. So there you have weight comma weight, here you have weight ampersand comma weight ampersand. So this is we are passing it as reference, repassing it as reference, and then void weight sum underscore weight ampersand w1 and weight ampersand w2, and you start the body of the function. Okay, and then you can do the same. Okay, just like you passed it by a value, and then you have a default copy constructor which is used to create a copy of a already existing object of a class type. So generally we will be having the form. Okay, right, so x, okay, maybe like x ampersand. Okay, you will be having like x ampersand. So you consider this x as a class name, and this compiler is going to provide a default copy constructor to all the classes. So we have the copy constructor syntax: class name, const class name, ampersand object name. Okay, so this is how you create a copy of an already existing object of class type. So it is, since it is going to create an object, it is called as a constructor. Okay, however, it creates a new object which is an exact copy of the existing copy. So which means that you call it to be a copy constructor. So here you have hash include IOStream using namespace std function class sample copy constructor. You term it as private, okay, in x comma y, which are the data members. So in the public you go for sample copy constructor. Okay, sample copy constructor. You initialize the variables x1 and y1. Okay, so here we are creating a sample copy. X is equal to x1, and y equal to y1. Okay, and you're going to go for the copy constructor, sample copy constructor, const sample copy constructor ampersand sample. So here you said x is equal to sam.x and y equal to sam.y. Okay, and finally y display, you are going to print the result. Okay, see out x, okay, and then y. Okay, you are going to go with it. So in this previous slides, like you started up with a sample copy constructor, okay, and then copy constructor we display. Okay, the second part of this program, we have the main function, which is int main sample copy constructor object 1 10, 15 sample copy constructor object 2, which is equal to object 1. So here you are going to create a normal constructor, and then here you create a copy constructor, sample copy constructor object 2, which is equal to object 1. Okay, now you are going to print the C out. So here you have the normal constructor, okay, and then the object 1 dot display, and C out copy constructor, it is object 2 dot is display, and finally return 0. So normal constructor like 10, 15. Similarly, copy constructor the same what you have in the normal constructor. So it is 10, 15. And you return object from the function. So function can also return objects, maybe like either by value or by reference. When an object is returned by the value from a function, so here a temporary object is being created within the function, which is going to hold the return value, and this value you are going to assign it to another object in the calling function. So here in the example, we have a syntax, we have class underscore name, function name, okay, the parameter list, and then you have the body of the function. So you have class name, function name, within that you have the parameter list and the body of the function. So we generally differentiate between the structures and classes. So definitely structure, definitely it is same as the class, but there are some differences. Whether it may be like security or maybe authentication features, definitely structure is different from class. So you can say a structure is not secure, it cannot hide its implementation details from the end user, whereas a class is more secure. You can hide the programming, you can hide the design details, you can hide the implementation details from the end user. So here in class, the members of the class are private by default, and in structure, the members of the structure are public by default. With the case of classes, the memory allocation happens on the heap, whereas in the structure, the memory allocation happens on a stack. Okay, so as you know, like stack means first in last out, last in first out. Heap means first in first out. So in the case of class, it is a reference type data type, and in structure, it is a value based data type. And then class, it is declared using the class keyword. Similarly, structure, we are declaring with the help of struct keyword. And then you have classes, objects, and memory static class data. So here you define static data members within the class using the static keyword. And when you declare a data member as static, which means that irrespective of the number of objects which is being created, you tend to create only a single copy of the static member in the main memory. And you can say that all objects of a class, you can have the same static member, and all static data members are initiated to 0 when the first object of the class is created. So here the static data members are visible only within the class, but their lifetime is their entire program. So this is all about the class, objects, and memory static data. And finally, we are going to end up with const and classes. So here the const keyword is used to make any element of a program constant. And if we declare a variable as constant, means we cannot change the value. Okay, so a const variable must be assigned a value at the time of the declaration. You cannot change the value. And once initialized, if we try to change its value, then we will get a compilation error. So maybe we'll we'll consider examples also of how you take a constant data member of a class. So data members are just variables declared inside a class, and const data members are not assigned values during its declaration, and const data members definitely they are assigned values inside the constructor. So here we have an example of constant classes like hash include IOStream using namespace std function class A. So here you define the const type. So const int x. So const int x means you are going to go for the constant data type. Okay, const int data type. So here you are going to go with the public variable. Okay, A now int y. Okay, so here you are going to pass x is equal to y and you are going to close it. Okay, and finally you are going to have in main function a of 5. Okay, and then you are going to return 0. So this is implementation of constant and classes in C++. So these are the independent works. I've already given them in the Google Classroom. Yes, I am telling you that this is the last independent work I am posting them. Efficiency and complexity, concrete measures for performance, big O notation, and then general specification of trees, implementation of trees, and then recursive algorithm. So please complete them at the best possible means. And of course, and after this, we'll have the independent work of open-ended project. So we can choose a application oriented program.